Aloha, my name is Katsuta, and I am majoring in civil engineering here at HONCC. My overall goal for this project was to design a 1U CubeSat structure, a 2U CubeSat structure, and a CANSAT structure. CubeSats and CANSATs are basically miniature satellites. Their original purpose was to provide university science communities with access to space. Today, universities and government agencies use these mini satellites because 1, it provides the same info that a regular sized satellite would, and 2, most importantly, it doesn't cost as much. CubeSats and CANSATs serve the same purpose. The only difference is the shape of each model. One is a cube and the other is a can. CubeSats are classified by their sizes, which range from 1U to 1.5U to 2U to 3U, 6U, and even 12U. The capital letter U refers to unit, and a single unit has a standard dimension of 10 by 10 by 10 centimeters. 1U CubeSats are built to the standard dimension and typically weigh less than 1.33 kilograms per unit. For CubeSat competitions, the CubeSat shouldn't exceed the standard dimension nor the weight of 1.33 kilograms. Similar to the 1U CubeSat, the 2U CubeSat has twice the height and shouldn't exceed double the weight, which is 2.66 kilograms. As for CANSATs, the diameter should not exceed 125 millimeters, nor should the length be longer than 310 millimeters. Also, the mass should be between 590 to 610 kilograms. To create the designs for the structures, I used a computer software called Autodesk Fusion 360. Before this project, I had no prior knowledge of how to use the software. I had to look up online tutorials, and thankfully one of my mentors had experience with the software, so I was able to learn the basic tool functions and how to navigate through it all. Many features are taken into consideration when designing these miniature satellites, such as determining how to prevent overheating, what is the thickness of the walls, and how many pieces should be used, and are these components assembled to make it easier or accessible to the engineer. What type of material should be used, and is it durable to withstand during and after the launch process? Also, where the camera should be mounted. I had many challenges during the design stage. As you see in figures 1.6 and 1.7, designing the cutouts in the walls was very tedious. I had to create multiple lines and constrain each line to a specific coordinate, which then allowed me to constrain other lines to a corner. Doing so, I was able to develop the thickness of the walls and the shapes of the cutouts. Unfortunately, the walls were too thick and the corners were very sharp, shown here in figure 1.8. As shown in figure 1.9, I was able to trim down the sharpness of the corners using the Flet function tool. In figure 2.0, I took the exact same model of version 1 of the 1U CubeSat and doubled it, and stacked it on top of each other, which I later found out was a big mistake. The corners are too sharp and the walls are too thick, and the top and bottom and middle faces have no cutouts. I attempted to extrude the faces in the middle, which resulted in figure 2.1, but I realized a mistake after the extrusion. The wall thickness of the top layer was way thinner than the bottom layer. After designing both the 1U and 2U CubeSat, I realized I was building upon my mistakes. So instead of starting on the CANSAT structure design, I decided to redefine the 1U CubeSat. For version 2 of the 1U CubeSat, I started the process all over again. I went into more details with the sketch. In figure 2.2, I constrained multiple lines to specific corners similar to what I did in version 1, but this time I was also focused on having enough clearance for the corner mounts, the PCB mounts, and the wall cutouts, which is shown here in figure 2.3. I made sure to adjust the spacing of each line to provide the proper thickness. With this thickness, I was able to not overlap the PCB components and reduce the total mass of the unit. Figure 2.4 shows the design on the top and bottom faces. I wanted to use X's in the circles to indicate that those are the top and bottom faces. In figure 2.5, compared to version 1 of the 1U CubeSat, version 2 has a total of 10 components instead of 3, so that every side of the CubeSat can be accessible to the engineer. Also, the side walls have the open circles, which allow for a possible placement of the camera viewport. Also for this design, the material I want to use is aluminum alloy 6061. which is the most commonly used aluminum for structural applications. And in figure 2.6, this is my complete version 2 of the 1U CubeSat. In conclusion, I was able to design a 1U and 2U CubeSat structure. Though the first versions of each design had some flaws, I was able to use these flaws to understand what should be adjusted for the second version of the 1U CubeSat. The design considerations and earlier mistakes allowed a steady progression of version 2. With more time, I'm certain I would be able to redefine the 2U CubeSat and also design the CanSat structure. For future plans, I hope to add the inside components for version 2 of the 1U CubeSat, and I want to complete a second version of the 2U CubeSat. After completing those tasks, then I'll start on the CanSat structure design. And hopefully all structure designs will be ready for launch. And that is my project. I'd like to thank the National Science Foundation for funding this project, and thank you to everyone who helped me throughout the summer, and much mahalos to my mentors and faculty advisors. Mahalo.